Testing 1, 2. All right, we are in business. Let me just get the volume down a little bit. There we go. Okay, let's code. Still working on the seam carving algorithm for the coding game puzzle of the same name. Making some good progress. Let's try another test case here. Got the first 2 ones to pass. We're going to try this one here. So that's our input. Actually, first I'm just going to copy the test that I have here. That. Now I'm going to get this. Let's see if I can just copy it here. Boom, just like that. Amazing. I gotta change the name. Height 16, width -2. Oh, so that's definitely not gonna work. Because I haven't, my algorithm doesn't work with removing more than one seam yet. So what are we expecting here? We're expecting 270 and 441 as an output. So I have to go. I need this to be here. There we go. So I think we've got our test set up properly. Now let's think about this here. Do we want the remove seam function to work that way? It made sense to just have it remove one seam, but to remove two, I don't know. Well, yeah, why not? Let's have it work this way. We could always change it later. So we should rename this to remove seams. Remove seams. Unless. Yeah, let's just do that for now. Okay, let's run it. One failed. Yeah. We received 270, so it removes the right one. But then that's it. So, okay, we've got some work to do. Because that's not going to be easy right now because I've got this algorithm. All it's doing really, it isn't actually removing the seam from the image. It's just returning the value of the seam that it would be removing. Because so far, that's all our test cases required us to do. But now, if I am to give, if I'm to be able to give the second seam's value, well, I actually need to remove the first one from the image. And then compute again. So how do we do that? We need to keep track somehow when we find okay, this is where we, no, wait. This is where we find the path of least energy. This here, okay. Nose is itchy. Okay. So we're just basically finding the lowest, yeah, the path with the, okay, we're, what are we doing here? Yeah, okay. We're looking at the last row of pixels, and we're finding the one that has the least cumulative energy. Right now we're not storing which pixel that is. And how would we remove that from the image? We would need to go back up. I guess we would need to store each scene. Work that differently. Yeah. We would need to store the seams somewhere. Does that make sense? Let's take a look at our algorithms description. Here. Computing seams. Consists of finding the path of minimum energy cost from one end of the image to another. Starting with an image such as this. Calculate the weight density, that's what we do. After adding the energy of each edge, a list of seams. Okay, so I do need to generate a list of seams. Seams can then be calculated via the dynamic programming approach. Seams are ranked by energy, with low energy. Seams being of least importance to the content of the image. Seams can then be calculated via the dynamic programming approach. Okay. Well, in any case, what we're going to do is actually keep a list of seams. I don't see any way around doing that. And we're going to do that in here is where this would make sense. what are we doing here? We're going down row by row, and we are this is where we're picking which one's the smallest. Okay. How would we identify that? So right now, I've got this, it's looking at the energy and it's just saying, okay, this is the value that is the smallest. What I need to know, the column index of that value. So what I would need to do is here, after doing that, so scenes, we'll have a scenes. Okay, so let's clear property scenes. Where did it put that? Oh, in here, does not have. Oh yeah, that's right. Okay. We want it to be private. And we're going to have this be an array of numbers. It's just going to store the row index. No, that's not right. It has to be an array of numbers, yeah. So it's an array that's going to store arrays of numbers. And those arrays of numbers are going to be the sequence of row indexes that constitute a scene. I think that works. So, okay, so this dot scenes dot push. Oh no. Hold on. How am I gonna go about doing that? We need some sort of intermediate value here. So const seam is an array. Let's type it properly. What am I doing? Number. Okay. Okay, so now. Oh wow, no, that's not gonna work. Ay ay ay. I guess I need to store this in the pixel itself. Yep, I need to store this in the pixel itself. Cause I'm going down row by row. So how would I keep track? Huh. That is very interesting. is will. So I'm starting at the top, so each are we starting at the top though? Let's see what the instructions are for a vertical path is a sequence of pixels, so that, in other words, the path contains exactly 1 pixel per line, and consecutive pixels are vertically ordered. Energy of a path is the sum of the energies of its pixels. I think we're looking at the bottom. So yeah, that's interesting. So right now I'm going down row by row and I'm just looking at what's on top. I'm going, okay, this is what your accumulated energy is. Going down, this is what your accumulated energy is. Row by row by row by row. Is there a way to store this somewhere else other than? No, I think I'm gonna have to store it in the pixel. I'm going to have to store it in the pixel. Hey Kramer, how you doing? Keep coding, brother. I will. I will. So let's see. I could make this a scene. Wanted to interrupt you with this important message. Yeah, I saw it on Slack, the GitHub sponsors. I didn't have time to check it out. I had to start my stream, but I will once I'm done. Okay, so it's going to be an array. Yeah, you like it? You like the music? Good. How's the volume? Can you hear my voice over the music, or is the music too loud? Good. Music volume is fine. That's great. Alright, how am I going to do this? This is more like a linked list kind of thing. I really just need to have the parent came by to get me some frog legs. Yeah. Just need to stay in the channel for a few minutes and you'll be rich in frog legs. And then you can buy my whatever, I don't remember what I called it in my store, but you can basically purchase the privilege of choosing the next kata I'll be working on, or puzzle, or whatever. So what are we going to call this? Parent, pixel, parent pixel, row index, column index, column index. It's descriptive enough, right? I shouldn't. And it only needs to be a number. Do I need anything else other than just a number? I don't think I do. Just initialize it to 0. Do it that way. All right. So now my pixel is set to retain the information that I need. So all I have to do here is to figure out which pixel am I getting this value from. Need to give it this here. Nope, need to give it this value here. So if I go, let's say I do Gonna have to put that in a list, I guess. But even then, that's not gonna be. Let's think about this here. I am getting getting a value here, here, and here. Now I determine which one is the slowest value out of the three. But I need to know okay. So I'm gonna have to make this a little bit more complicated. Let's see here. I need to comment that out before I screw something up. That's what I need to do. If it's the top row, then we just pixel.energy, so that's fine. So let's start here. I need some way to store. So going northwest is going to be equal to, oh, we still need it to be let. Northwest is going to be equal, I need the index. So the index is going to be, we'll call this column indexed. Column index. And we'll, that's going to be x minus 1. Right. And then I need cumulative energy, which is going to be infinity at first. Actually, I can make that a const. The problem is, what happens when if I'm on the edge here? If I'm on the edge, I can only look at the edge. There is no northwest, basically. Okay, yeah, that'll be fine, because it won't be selected. So I can do it that way. Okay. Const northeast. Just copy that. And northeast is x plus 1. Right. And north I never have to worry about because it's always going to be, there's always going to be a north. Okay. So I think I can pretty much just do the same thing I was doing here. Now this is where this needs to change. Northwest dot cumulative energy. Northeast dot cumulative energy. And then once I'm done with that, I can just do const north equals whatever I had going on here. Oh no, right, I've gotta, so I might as well initialize it here. North equals same deal. Them dudes here. And this is just the X. There we go. And then I can just go something like this. North dot cumulative energy. Yep. I think that would work. How about we just do X index here? X index, X index, and then I can do northwest dot X index. Which one is better? I think I like this better instead of having the numbers straight in there. This is northeast. And this is just north. Okay, now this is where I need to change things up a little bit. I need to get, I'm interested in the least, the one that has the least energy, but I also need to know what the column index is. So really I only see one way to do this, and that's to, I could sort it. I could use a reduce or I could use a sort. If I sort the array, okay, so first I need to shove them in an array, just a temporary array. And then I put northwest in there, and northeast in there, and then north. Okay, and then I can sort. I can sort or I can reduce. Which one would I prefer? I think sort. Sort would work. Sort, and then I need a compare function, which is a, let's see, A, B. And then if I want to sort it, let's say with the lowest, from least to greatest, I need a positive number. I think I just need to do A minus B, right? If I do A minus B, let's just look at the documentation of this one. In array sort. Pretty sure they have an example. A is less than B by some ordering criterion. That's what we want. Right? Return minus one. So if we return a minus number, A is less than B. So if we do A minus B, it will be a minus number if A is smaller. So that works. That's what we want. We had it right, I think. Y. Oh, right. Okay. A dot cumulative energy and B dot cumulative energy. Simple as that. That should work. So now our array is going to be sorted. And what do we need to do now? We need, let's call this sorted array. Now we need to do the same thing we were doing here. Now we know that we can just grab the first element in our sorted array. Pixel cumulative energy, so the first element in our sorted array, and we give it the cumulative energy plus our own pixels energy. Yep, makes sense. Now, I also need to store the parent pixel column index. I don't know if parent is the proper term here, but sure, why not? And that's going to be, well, it's going to be this sorted array 0 dot x index. There we go. So that should work. It should work. Is there a reason why it went? So the first row, we are basically just putting cumulative energy. We're just, okay, it's the first row, so there is no cumulative energy, so we're just basically assigning the pixels energy to that, which makes sense. And there wouldn't be a parent pixel column index because there are no parents. It's the first row. So we have that set at 0 time. That's fine. Then we go down. We calculate which one. We get the value for each one. Yeah, here is what we're doing. This is what we're doing here. Okay. Then we sort it according to that value. Then we get that value, the smallest one. Out of the 3, we add our own value to it, and that becomes the cumulative energy. And we store the column index of whichever pixel had the smallest cumulative energy. And so on. This will give us a way to track our seam and remove it from will it though? Huh. No, not exactly. Because if I follow it from the bottom of the screen to the top. How would I go about removing? Yeah, it might work. Okay, well, first, let's just make sure we didn't screw up our previous test cases. Let's run. If I'm doing this right, it shouldn't affect the previous cases we had. Okay, so good. We at least know that. So we can, well, I'll leave it here for now. I won't delete it yet. So now the next step is, once we are done computing the cumulative energy of all the pixels, we need to find the path of least energy, which is what we're doing here. But again, that's going to be a problem because now we're not only interested in the cumulative value, we actually want to know which pixel, which index it's at so that we can remove it from our pixel array. So I think I'm going to have to proceed in pretty much the same way I was proceeding here, putting them all in an array and sort it. Is there another way to do this? Oh yeah, I don't need to. I can keep doing that with the reduce here. I've got access to what I need. I just need to store stuff. I need to store it. Am I gonna store it and make an object here? Yeah, that's exactly what I'm gonna do. So instead of just being an infinity number, I'm going to make an object that will have, what is that object going to have? It's going to have a cumulative, well, it's basically the same, yeah, it's basically the same type that I had going here, basically. I think that would work, right? X index, now the X index is going to be 0 to start with. Cumulative energy is going to be infinity to start with. And now return math.min between p dot cumulative energy and c cumulative energy, except I won't just return it straight like this. I just need to, oh, rats, we're stuck with the same problem if I do it like that. Oh, but here's what I could do. So I've got my P, I've got my C. I could put them both in an array and, yeah, sort them just the same way I was doing it. So let's do it like that. P, C, and then sort A, B, A minus B, A cumulative energy, yeah, minus B cumulative energy. So we got my sorted array. Then let's just call it sorted array, same thing. Then I'll return an object with the x index being whatever sorted array 0 dot how come I don't have C is a pixel and P is this thing here. This has an X index and this has, my pixel has what? Parent pixel column index. So it's not actually storing. Okay, so I need to turn this into the same type. Okay, I'm not gonna do that straight in here, so I'm just gonna go const current. It's just gonna equal C. No. X index. So that's going to be the X. Simple as that. And then we need our cumulative energy, which that we have access to. There we go. And now, okay, I think we're getting there. And here I should have access to my X index. There we go. Good, and I also need the cumulative energy. So cumulative energy is again our sorted array 0 dot cumulative energy. Everyone's happy. Transpiler's not complaining. Okay, so that's a start. Now let's just run our tests to make sure we didn't screw up anything with the previous test cases. It shouldn't. Let's see, what are we? Oh, we are returning something slightly different here, so we should get past that cumulative energy. That should be. We should still be passing our tests, except for the last one. Okay, we're good. So all that we need to do now to get our last test to pass is actually remove. No, it's to first store. First store. Let me think about this here. Yeah. So I need to store the seam, the value of the seam that I'm removing, because that's going to be our output. So I need to store that somewhere. And then I need to basically do all of this all over again. And once I'm done, I can just return the value, the string with both values. Oh, I know I only have to do that twice to pass this test case, so I'm not going to worry about generalizing it. That's something I learned. If I want to do TDD right, I have to be careful not to jump ahead and implement generalized solutions right away. So I know my test case only has 2. Seems to remove, so that's what I'm going to do. I'm just going to store this here. So const, no, we're going to make the let return, oh, we're going to call this output. Now, initialize it as an empty string. Instead of returning here, we will simply take our output string, and we will make it equal to this thing. That takes care of our first scene. And we need to add a you know what? We won't do that for now. Yeah, we will. We'll just add new line character. Okay, so once we're done with that, we need to do all of this over. Oh no. Then we also need to remove all those pixels. How am I going to do that? Now I have the information I need, I think, because if I look at path of least energy, I've got my x-index. I've got my x-index to get me started. I got my x-index to get me started. So if it's starting here, that means I can access my pixels array. Pixels array here. And that would be the pixel that I need to remove. Right? Oh, no, it wouldn't. It would need to be, let's see, pixels, it's got to be the last row, so pixels dot length -1. And now we have our last pixel, the one we need to remove, basically. But we also need to know which one I need to remove next. So if I was to do this by hand, you know, I'm going to need to do this in a for loop of some kind. But if I was to do this by hand, I would then go dot that's the next one I need to remove. Let's see, I need to do 2 things here. I need to store this somewhere before I get rid of the pixel, because otherwise that information's gone. So that would be the next x index to get rid of. Whoops. Next x index to get rid of. And then I could go ahead and remove the pixel. Now, how would I go about doing that? I would just use I could do it in place. Actually, I would have to. So a splice would be the right one, I think. Zero-based location in the array from which to start removing elements. That's correct. Removes elements from an array and, if necessary, inserts new elements in their place. No, just removing. So it takes the start and it takes a delete count from which to start removing elements at. So we know, so pixels dot length -1. And we want to, from that row array of pixels, we want to remove the one that is at path of least energy dot x index. There we go. And now we've got our first one done. Then we would go, okay, so we would need to make this a let. Okay. So then we can just do next index. Okay. And then we'd go pixels, not pixels dot length -2. Then we go splice. Oh, but first, we would need to update this to pixels dot length. No, that's not right. This is storing the index of the next one. And first we have to remove this here, yeah. So then when we move on, so we have, okay. So we should have 2. Let current index to remove equals this. And let next index to remove equals this. Then we can go and just remove current index to remove. Oh, I don't need to do this. I just need this here. Silly moi. There we go. Okay, so now that's removed, and we've got the next one. All we need to do is update our current index to remove to our next index to remove. Then update our next index to remove to be pixels dot length -2 -2, and then that would be current index to remove dot parent index, right? We're taking this, we're making it the next, the current one we have to remove. The next one is going to be the current index parent. Yep. And then we proceed with our splice. Okay. And if we were to do it a third time, it would look like this. Right. So I think we've identified what our for loop could look like. Right, if we were to rewrite this with a loop, how would we go about doing that? Well, these two, though, at least this one. Oops, I'll keep that here. This one would be outside the loop, for sure. I would need to initialize this one too, as well, outside the loop. But wouldn't know yet what this is. Just leave it like that for now. Then I would have my for loop for let I equals, oh, we're looping in reverse, right? So I is equal to, let's actually make it X. What's that? No, let's make it Y. It's Y. Let Y equals pixels dot length minus 1. And we keep looping until Y hits 0. So as long as Y is bigger or equal to 0, we keep going. And then I minus minus. No, it's not I, it's Y. Y minus minus. So unless I'm mistaken, this loop would start from the last row of our pixel array and loop through each row, going back to the top of the image. And at each one, we could do this. So we start by storing the next index. Then this would just be the Y. And this could just be the current. Current index to remove. Okay. Then we actually remove it. And then once we're done removing it, we need to update the current index to remove. Current index to remove is what used to be the next index to remove. And now we loop Boop, to the next one. Our next index to remove becomes, yep. I think we've captured the essence of what we're trying to do here. Right? Not sure. So we're starting at the bottom. This is the X index of the last row for the path of least energy. So then we loop through each one, starting at the bottom, and we're storing the next index to remove. Yes, then we're removing the pixel from the list. And then we are making our current index to remove, the next index to remove. Then we loop again. This becomes whatever the top row, not the top row, but the row on top of the last one. And then we already have that as being the next index. Yeah, that works. That should work. Okay, so once we're done doing that, that is basically removing the seam from our picture. What do we do next? We have to do all of that over again. So let's make this a big loop. 4. Let I equal 0. So let's make it 1. Till I is smaller than let's just make it 0 next. I is smaller than 2. Because I is smaller than 2. I plus plus. So then we shove all of that stuff in here. Like that. Which will run twice, right? 1 for the 0, 1 for the 1. Then once we're done, we'll have an output of our first value and our second value followed by a new line character, which do we mind having the new line character? Let's get rid of it. So the last new line character. So return output dot trim right. Trim right. I think trim right. Hold on. Trim right. Removes white space from the right end of a string. Will it remove a new line character though? I need to look that up. So dn trim right. Trim end. Huh. What's the difference? One's probably deprecated, I guess. No, there's no more trim right, apparently. It's just trim end. Following example displays the lowercase string foo. Okay. That's it. Hmm. Oh, that's interesting. Let's see. JavaScript. Remove new line from end of string. Oh, really? That's the best way to do this? String the trim does in fact remove new lines and all other white space. Okay. White space in this context is all the white space character space to have no break space in all the line. That's what we want. Oh wait, string.trim. This will remove it from the beginning as well, I guess. Both ends. So I'm gonna gamble that trim.end will do trim. Well, that's interesting. I've got trim right, but I don't have trim end. Weird. Well, that's interesting. This is a string. I'm getting trim right as a function here on the string object, and the documentation is saying there is no such thing as trim right. I've got to look that up. JavaScript. Trim right. Ah, okay. Trim right is an alias of this method. Where would I have seen that? Oh, right there. Okay. So we're in business. So we just do output trim right and we should get what we want. All right, let's see. Run our test. And everything breaks. Yep. Starting with the fact that there is no trim right. It doesn't like my trim right. Well, that's going to be a pain. Because if I try to do trim end, then the IDE is going to complain. But when it tries to transpile, it'll work. Let's try that. My tests are still gonna fail, I'm convinced, but not wet. Trim end doesn't exist either. Okay, well we know that trim exists, right? You're not gonna bug me with trim. I can probably just use that because I don't have a space or a new line at the beginning. I don't want one anyways, so how about we do that? Oh, okay, well our other tests are still passing, so that's good. Now we're still only outputting 270, and that is odd. path of least energy, 2 string. I am looping here. No, yeah. Should be doing it twice. I am plus equal. Okay, that's our problem here.
1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, funk.
Let's see. Oh, now 13 of them failed and only 2 passed. How interesting. Okay, this is getting a little annoying. Okay. Let's see. We were expecting $270. Receive 270. What about this one here? We're expecting 120. We receive 120, 120. Right. I'm an idiot. Okay, that would have been too easy.
1, 2,
Let's get rid of that loop.
2, 1.
Of course, that wouldn't work
2,
because now I'm
1,
having 2 value outputs for every case, even when there's only one. So
2, 1, 2, 3, funk.
So I actually need to parse this and get the amount of seams we have to remove from this input here. So let's see, this will become aligns. And then we'll have const pixels equals lines, and then all of this good stuff here. Control X, Control V. Just run the tests again, make sure we didn't screw up anything for all of our test cases. Okay, we're good. Now, I need to store const seams to be removed. Equals lines.
1, 2, 3, funk.
It's, which line is it in our input? It's actually just the first line, second line, third line. 0, 1, 2, index 2. Index 2. And we need to split that. There's a character we don't give a damn about there. Okay, so now we have an array. We don't care about the first element of that array. We want the second one, which is the seams to be removed. Or actually, it's not the seams to be removed. It's the amount of columns we want to end up with. This is the original amount of columns, so we need both. Okay, so now let's get const. that width, height equals lines. We're looking at lines 1. Then we also want to split that to a new line. No, not new line. To space. So this minus our W will give us right, hold on a second here. This is a string, right? So I need this to become a number. So parse int minus, let's make all of that. No. Splitting it so we end up with an array. Just gonna map that array to numbers. There we go. So this should be a number. Yep. Minus, actually it's the other way around. We're taking W and we're subtracting the final. Yep. Okay, so now we end up with the seams to be removed. Okay. Okay. So now that we have that information, we are able to loop. Shouldn't have gotten rid of that thing. So let y. No. Let x. Let's I equals 0. Okay, and we keep going. As long as I is not bigger than R seems to be removed. Oops. This should be here. This should be. This should be right here. Okay. I plus plus. Okay, then we grab everything that's in here. Whoa. X. B. Is that right? We get our lines, we get this, we get that. Pixels, let's space here. That's just for the cases where the image is so small that there's nothing really to be returned. And here is do this. I compute the gradient magnitude for the entire thing. I compute the cumulative energy. Then I get the path of least energy. I add that to my output string. And then I loop and remove the path, the seam. Once I'm done with that, I do it all over again if I need to remove another seam. Then once I'm done, I return the output. Let's see what was going to happen. I have a bad feeling. I am not confident, but we'll see. Okay, we're getting an error. What is the error? Cannot read property grayscale of undefined on line 117. That is part of our compute gradient magnitude. How do I get to a position where and that's on the last test too. All the other ones passed. But on the last test, at some point, it's trying to run this here and this one here. And the X index ends up not being in range. How can that be? How can that even be possible? Could it be that I gotta see this because I don't. X is actually being fed to us by the for each function. So how the heck I don't know. We'll find out. Time for some debugging. Oh no, crap. It's gonna stop everything. I don't want to debug every single test. Let's just make this one. There you go. Okay. And see. Okay. So far as we can see, X is 0. X is 0 here. It's our pixel. What are we doing here? Ah. We are looking, okay, y minus 1. No, but if y minus 1 is y is not 0, so it shouldn't be a problem. Well, and we know that we're not out of bounds here because if we tried to so we're at 0, 0 basically. Why don't we have a grayscale? Oh, we don't know that this is a problematic one. I should just see. I should just do this, I guess. Let's try. Oh, I could have just done. Whatever. Let's run it again. Oh. Well, isn't that a... You don't consider that an exception? Really? Grayscale. Oh, it's this one here. Okay. It's this one here that's causing this problem. If y is not equal to a without length minus 1. So yeah, I'm supposed to guard against that. It's so odd. Line 17. Okay. Let's run the debugger again. Sorry. All right, let's just continue until we get some weird values, I guess. We're interested in an x that would be somehow out of bounds, I guess. No, x is 1. Shouldn't be a problem. X is 2. X is 3. X is 4. 5. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. How wide is this thing? 30, okay. 18, 19, 20, so far so good. Okay, 29, 30. Okay, and we're back to 0, which means that our loop went around and we should have removed a no, hold on, that's for each row. So yeah, that's just another row. Our y should be now 2, that's right. So just oh, but this is gonna take forever if I do it this way. Y is 3, yeah. 31. 31, and I'm going through up to 30 because why am I going only up to 30? Nope. What happened there? I don't know 30. Oh, okay, that's correct. Okay. And now our y is for, how deep is this thing? 16. I'm not going to go through all of that. Isn't there a way to stop this when I need to read up on the debugger a little bit. Breakpoints. Add a function breakpoint. Can't I go like, okay, you here. Add inline breakpoint. Maybe that's what we want. Can I make it like a specific edit breakpoint? Oh, okay. Hit count. Hit count. No. Expression break. When expression evaluates to true. So how about y equals 16? Oh no. Let's make it 15. Hi, Dax1. Good to see you too. Well, I don't actually see you, but good to hear from you. I don't know if this is going to work. First time I really try this. We'll remove this breakpoint and we'll keep going. Maybe. Are we stopped here? What's going on? Why don't I see anything here? Oh yeah, the debugger just stopped. Let's try running it again, see if this will work. Nope. I'm doing this wrong, apparently. Oh, maybe I just need it to be like below. Add conditional breakpoint, yeah. Y is equal to 15. Let's try that. Oh, it did work, okay. I guess because I had it on this line, Y was undefined before, I'm guessing. Okay, so now, and we're interested in our, let's get in there, in our X. Okay, so X is 0. Okay, I don't actually need to go this deep. Let's just go like, X is 1, and we know that our Y is 15. X is 1, and our Y is 15. Okay. Let's keep going. Let's keep going. With the 3, we've got like 30 of them to go through. Can I just maybe continue? What would happen if I did that? No. I just screwed that up, didn't I? Let's try it again. Learning how to use a debugger. Okay, so I think I can add another breakpoint here. This is our culprit here, so add conditional breakpoint. Now we want to stop when our x is going to be, let's say, 29. And let's continue. Great. Okay, this is, once you know how to use it. Oh, but now our y is 1. What's up with that? I was kind of hoping that, oh, okay. I know what I'll do. Let's try this. So we want to break here if y is equal to 15 and x is equal to 29. Just restart the whole thing. Oh, okay, so that's interesting. That is interesting. Let's try to maybe put that breakpoint here instead. So what did we say? Y is equal to 15 and oops, x is equal to 29. Debug. Okay. I think we're in business. So 15, 29, let's see. Let's get let's watch these here. That's really what we're interested in. And let's step over. Or step into, I don't want to step into, I want to step over. Okay, what's next? 15 and 30, so that's, okay, that's our last x. Then it should move to okay, it's done with this function. Now it's computing some of the stuff, it's doing some other things I don't really care about. Okay, what just happened here? We're back in. Okay, that's interesting. What are we doing here? Okay, this is the part where we actually remove our pixels. Why it keeps me coming back to that every time it... Not every time. Okay, now we're... Okay, this is what I'm interested in. Oh. Oh. What have we got here? Right off the bat. Boom. We seem to hit our exception. Yeah, I don't want to see the whole internals of the exception thing. We'll just throw it already. Huh. I am perplexed. Seems to me okay, so it's happening on the second go around for this thing. So I could probably set that breakpoint. And we want I to be equal to 1. So let's see if that'll work. Because we know the first iteration works. Let's try to skip to the second one and see how far we can get there. Yeah, we don't actually get to that thing. So maybe if we do I equals 1, and let's say, oh yeah, we probably wouldn't, because let's make this 27. This really shouldn't have changed, so okay. Oh, I have a feeling it still won't work. Yeah, that's right. And I think I know why. Let's see if we modify this, just completely drop the Y. Nope. Still doesn't, probably because it doesn't have access to the I from there or something. I'll just remove that for now. And let's try, let's see, let's put a breakpoint right here. Okay, so I is 0 right now, so we know that works. We're just gonna continue, and it'll, will it stop once it hits it again? I guess not. I thought it would. I was mistaken. Oh, maybe that's because, where's our problem? 117, that's inside the compute gradient magnitude. Yeah, okay, so we're good. So let's just step over quickly until we get back to what we're interested in. I don't do the whole thing. Ah. Okay. Let's try that again. Man. That's not an easy one to debug. Especially since I don't know how to use the debugger. Okay, no, I don't want to get in there. I just want to go around again. Can we please do that? What am I looking at here? Just gonna do the whole thing. Yeah, why don't you do that? Remove the thing. It's making its way back up. Okay. So now technically pixels. Let's see. Pixels, pixels. Maybe enclosure. No. Global? Nope. Local? Yes. Our length should now be oh, well, it shouldn't be 31 now. This one's 29, so obviously something in our algorithm doesn't work, and that's our problem. If I'm looking at this here, we're supposed to have a length of 30. That is very interesting. Let's keep going for now. So if we're at Y0, I'm supposed to splice Y minus 1. Should take us out. Yep. Let's go for another go around this thing. Now our pixels array is still at 31 length, except for the last row, which is at 29. So there's obviously something not working there. And let's see where this blows up. Ah, I forgot to get in there. Anyways, I think we've identified what the problem was. And that is in here. Wait a minute. Where's that loop? In here, okay. This is our problem here. What is splice supposed to do? Removes element from an array. And if necessary, inserts new elements in data array. Start number, delete count. What if I leave it? Oh, this might be the problem. If I don't put something in there, what does it do? All right. Let's see. Endian array splice. Start. The index at which to start changing the array. If greater than the length of the array, start will be set to the length of the array. Delete count optional. If delete count is omitted, or if its value is equal to or larger than array.length minus start, that is. If it is equal to or greater than the number of elements left in the array starting at start, then all the elements from start to the end of the array will be deleted. If delete count is 0 or negative, no elements are removed. Okay, so it's, yeah, definitely not a good thing. Definitely not a good thing. Still, it wasn't removing them though. It's kind of weird. Anyways, this should be fixed by doing that. So let's just run our test now, see if that helped. No, of course it didn't. Did it throw an exception though? Yeah, we're still having that same problem. Oh, very interesting. All right. More debugging. I see debugging in your future. We're interested in this here. Let's do that. Let's run our debugger. We're no longer really interested in this here, so remove all expressions, and we're interested in this here. So our array is properly formed of 16 rows of 31 columns. Now we're supposed to remove one from each row through this thing here. Now what is this? Current index to remove, 30. Next index to remove, we don't know yet, which is fine. I'm gonna keep this to watch. I don't know that that's correct though, but anyways, we'll keep going. Next index to remove. Is going to be 30. Okay. Now this is where the removage is actually supposed to happen. Pixels.length -1. There's our problem. or another problem anyways. This should be our Y. Oh boy. Debugging works. You do find You do find mistakes. Okay, but I have a feeling that won't be sufficient to fix our problem. We'll see. Oh, it might be, actually. It very well might be. Let's see. Come on. Come on. Oh, yes! Okay, so let's bring all our tests back to make sure we didn't, somehow screw up the other test cases. And boom. There we go. Here we go. Right on time too, because I have to go. So I will be adding more test cases tomorrow, probably, as I progress through this lovely puzzle on codinggame.com. Hey, you're still around? Got nothing better to do? Free Steam. Hey, thanks, man. You take care. Oh, do I turn this thing off? There we go.